Howdy-ho, AP Stats students, and welcome to yet another exciting special problem. This time it's for Chapter 6, our probability chapter. If you haven't read the problem yet, basically what we have here are counts of different blood types from people living in Hawaii. You'll notice the first thing I did was I filled in the marginal totals, and there's one left to do. I need to find the grand total. And there's our grand total. That's really the first thing you should do anytime you encounter a two-way table. Remember, we worked on these back in Chapter 4, but now, being that we're dealing with probability, there's more questions that we can ask. All right, so question A, summarize the data numerically. Okay, so remember, with a two-way table, what we're looking for are percentages. Now, which way should I be calculating my percentages? Okay, are my row variables explanatory or are my column variables explanatory? Realize we're interested in by column, right? Do the different ethnicities have any impact on the types of blood that we're observing? So we're going to figure out for Hawaiians what percent have type O, what percent have type A, so on and so forth. Okay, so for Hawaiians, we've got I'm going to just round to the nearest percent, okay? So we've got about 41% with type O. And about 53% with type A. And about 4% with type B. And roughly 2% with AB. Okay, and now we'll do the Hawaiian white ethnic group. So about 45% type O. 47% A. About 6% B. And about 2% AB. Okay, and now moving on to the Hawaiian Chinese group. About 41% O. And 44% A. About 11% B, quite a bit higher than the other two. And about 5% AB, also quite a bit higher, more than double. All right, and our last ethnic group, the white group. And we've got 43% O. right on 40% A. %, B. And 4% AB. Okay. Okay, is there evidence? Okay, so question now, looking at what we just calculated. Is there evidence to conclude that blood type and ethnic group are related? Okay, so take a look. And so what we're saying is, if I told you a person came from, say, the Hawaiian ethnicity versus one of the other ethnicities, would you think, oh, that information is not going to help me guess their blood type at all? Or would you say, knowing that information might change my guess as to their blood type? Okay, and sure enough, you should notice, hey, look, Hawaiians, 53% have blood type A. Okay, Hawaiian white, lower. Hawaiian Chinese, even lower. And white actually has more O than A blood types. So you can see that the different ethnicities do have significant differences in what blood type they are. Okay, so I'm going to say yes. There is evidence of a relation between blood type and ethnic group. As we move across the table from left to right, we see a decrease in type A blood. Okay, and we can go into more detail and talk about, we see an increase in type B. And we can talk about A, B, we can talk about O. There's differences, but those two are real easy to point out. So I'll leave it at that. Clearly, knowing someone's ethnicity would help inform us of a guess as to their blood type. Okay, so they do appear to be related. All right, part B. A blood bank specimen is selected at random. Find the probability that it contains type O blood or comes from the Hawaiian white ethnic group. Okay. So question B, this was question A up here. Probability type O or, so union, Hawaiian white. All right, so we can just take all of the type O. That would probably be the easiest place to start. So all of type O. And then we'll take all of the Hawaiian white. Okay, and at this point, all the O plus all Hawaiian white, we've double counted, right? So we have to subtract away that intersection. There we go. All right, so type O, we've got that, 62,337. Hawaiian white, we've got 99.82. And then minus their intersection, which was 44.69. Okay. All over the grand total. Okay, work that out. And let's get a percentage there. So I'll say 46.8% roughly. Okay. Questions like that should be a breeze for you, so hopefully those aren't too bad. All right, question C. A blood bank specimen is selected at random. Find the probability that it contains type A blood or comes from the Hawaiian Chinese ethnic group. Okay, another pretty simple question. Probability type A or Hawaiian Chinese. So, same setup. Add them both together and then subtract the intersection that has been double counted. Okay, so let's see. Type A, 59,537. Hawaiian Chinese, 5385. And the overlap of A and Hawaiian Chinese, 2368. Again, over the table total. Okay. So 62,554 over the table total. And get a percent there. And about 43.1%. Okay, again, these should be easy, kind of your bread and butter type questions for two-way tables. All right, letter D. 2 blood bank specimens are selected at random. Find the probability that at least one of the specimens contains type O blood from the white ethnic group. Okay, I will go for the complement. Anytime I see at least one, I know the fastest way to do it is 1 minus none. So I'm going to go that route. Okay, so in this case, we were looking for at least one type O from the white ethnic group. So that means the complement would be not type O from the white ethnic group. Okay, so that's it's easiest. Rather than try to add everything else up and work it out, just take the total minus that, right? That's the complement. Okay, so we have that many random blood set specimens available that would not be type O from the white ethnic group. Okay, so 91298 145057. Okay. But remember, we are selecting 2 of these. So that's the first one, not being type O from the white ethnic group. Now the second one would have to be, again, not type O from the white ethnic group. So there's one less, both numerator and denominator. Okay, so there's our calculation. Got to work that out. 91297. Okay, divided by 145057 times 145056. And there we go. So we've got 1 minus approximately 0.396. So just over 60% chance. Okay, guess I should probably circle my answers. And there we go. Now, of course, you could have done the at least one. So you could have found the probability of exactly one. And of course, there's two orders to that. And then you could have found the probability of exactly two. So then you would have basically had three different calculations to add together there. But not a big deal. This is probably the fastest way to do it. All right. Letter E. Are the events type O blood and Hawaiian ethnic group independent? All right, let's give that a shot. All right, so let's do probability of O times the probability of Hawaiian ethnic group. And let's ask, does that equal the intersection? Okay. All right, so probability of O is the 62,337 out of the grand total. Okay, probability of Hawaiian ethnic group, 4670 out of, again, the table total. And the question is, does that equal O intersect Hawaiian? So O intersect Hawaiian right there, 1903. Okay, so if these are equal, we have independence. If they are not equal, then we have dependence. So let's take a look. Okay, big number. I'll just write that. All right, so, and we'll divide that by 145,057 squared. And there we go. That is 0.1 or 0.0138. I'm going to leave all the decimals because, again, these have to be perfectly equal. Okay, and on the right, this one's the easier one. We get that. Zero. And we can see, yeah, they're close, but they are not equal. Okay, so type O blood and Hawaiian ethnic group are not independent. Okay, and you could have checked it either of the other ways. You could have checked, does the probability of O equal the probability of O given Hawaiian, or does the probability of Hawaiian equal the probability of Hawaiian given O? And again, you would have failed both of those checks as well, because if you fail one check of independence, you'll fail them all. If you pass one check of independence, you will pass them all. Okay, hopefully that makes sense. Hopefully you're looking at this before you take the Chapter 6 test, and you are going to score really well on it. Thanks for watching.